First of all, my name is Dražen Rogulja, and from now on I will be the host. And let me introduce Marcin Szymaniuk. He is CEO and Tantus Data, and he'll share with us a particular starter's guide to building LLM-based projects. So Marcin, the stage is yours.
Yeah, thank you. And we have Bartek, which is our ML engineer. He will be presenting with me.
Hello, everyone.
Yeah, so let me share the screen. And please confirm if you can see my presentation. Are we good? Yeah, okay, so let's get started. So hello, everyone. We will be talking today about large language models, about LangChain, and how to use that in order to build something a little bit more complex than just ChatGPT prompt or a single prompt. So I need to warn you that it will be an extreme speed run, because usually when we work, we do these workshops for at least a day, but we try to get what's the most important, squeeze that during the presentation. What you will receive a link to what I'm showing you today, but there are two caveats. One is that it will be fast, so I would suggest to try to follow up through what we are showing, and then do that at your own time, like redo that, run it at your own time at home, especially that in the notebooks I'll share, you won't have the OpenAI keys. So what we will be presenting, it will be about code. I will show you some code, but honestly, code is quite simple. So, and the code is something you can figure out, but we also will be sharing lessons learned from our project from the past, what can go wrong, what to pay attention to, what works, what doesn't, and the business perspective as well. So my name is Marcin. I'm CEO at Tantus Data, and my background is in data engineering. We have Bartek as well, who is our ML engineer. He will be taking over the screen later on. And at Tantus Data, we help our customers with pretty much everything data related, from building data platform up to building custom machine learning model, custom GenAI applications. And let's get started with just saying that LangChain is a framework for building GenAI apps. And I'm telling you that because what the code I'll show you now will not really be LangChain yet, but we need to start with something else. So if you can scan the QR code, or maybe let me take the link and paste here. I assume I can paste it here, right? Chat. So you should be able to open the link, but I don't really recommend you to play around with it now, because you will very easily get lost, but you can play around with it at home later on. So what do we have here? Let me just make it smaller. So we are starting with basically a bunch of imports, and we are importing OpenAI library. We will be using OpenAI models during this presentation, and we define a client, and we basically define which model we are using. This time we are using 4.0 mini. Of course, we have 5 already, but it doesn't really matter, because what we will do next will be basically about sending just a simple single prompt. So that's exactly what you could do in ChatGPT as well, nothing fancy, right? So you say that you want to compose a poem that explains the concept of recursion in programming, and you want to make it short. So all it does, it basically makes a call, and you get a response which is quite complex object, but this is the actual content. So in a world of code where functions play, a problem emerges, but don't dismay. You could argue whether it's a good poem or not, but my expectation at least were not very high. So far, we are making a call to a model in a programmatic way, and that's it. So let me just stop here and mention a few things about this model selection, because it's actually quite important and quite not intuitive. Because if you're just using some library, some open source library, what you usually want to do, you want to use the most recent library, because usually that's the best. But when you select a model, you have to keep in mind that you will be basically making call to an external API. You will be paying for that. You will be waiting for the call result to come back to you. So when you make a decision, you cannot always go for what you think the best model ever is, because you will be paying for that. You will be waiting for the response, and sometimes the big model, usually the big model, is taking longer time to return the value, but also you pay much more for that. So that very much depends on your exact use case. And then what I would normally spend a lot of time on is this temperature parameter. But let me switch to the slides. But let me use it as an excuse to talk a little bit about tokens. So whenever you see some headlines about how good LLMs are, how good AI is, you see something like, oh, AI wins math Olympiad. And you could ask, okay, so if it's so good, why don't we just take what it says for granted and basically copy and paste from ChatGPT? The problem is, every now and then you also see something completely contradicting. You see memes like this one. So why is 911 bigger than 9.9? You ask that question, and chat basically comes up with some ridiculous explanation of why that is, which is completely not true, right? So why does it do that? First thing we really need to understand, we really need to pay attention to, is the fact that language models operate on tokens. They work on tokens. And that means that if you send a question, the question will be split into like words or tokens, or you can call them however you want. And when it will be producing a response, so let's say you ask ChatGPT to come up with some story. So it produces the output. And it produces the output token by token. It doesn't know the answer to your question right away. It produces it basically word by word. And if it produced so far the sentence, there was dark and silent, what could be the next word? It could be night. It could be evening. It could be room. And if it happens to select Pringles, then your story will be somewhat weird, right? And it's all about the probabilities of those words. So you need to keep in mind that the probabilities of those words pretty much depend on how the model was trained, what data it was used, how OpenAI or maybe how Google or another company trained the model. And this is something you don't really control. And I'm mentioning that only because you really need to keep in mind that it's basically token by token generation. And that's pretty much the explanation of why sometimes something goes wrong. In the older version in most models, you still can control the parameter called temperature, which basically controls the distribution of the probabilities. So you can make the model a little bit more creative or a little bit kind of more stable. But end of the day, I won't focus much on that because basically time flies. So I won't be focusing much about temperature and all the other parameters like top probability. There is parameter called seed, which is not what you would expect if you ever generated random numbers. But instead, all I will say is GPT-5 is not supporting temperature anymore. There are more and more reasoning models. So it's kind of, you can control less and less on how exactly the output looks like, mostly because the token generation is not that straightforward. It's not that you have just input and output. You will have some reasoning steps in between. So the reasoning model, the whole idea is that the models are reasoning. They produce some intermediate tokens, which you don't see in the actual output, but it's all about them planning on how they come up with the best possible answer. But I'm still spending quite a lot of time on tokens for a few reasons. First of all, you need to keep in mind that how exactly it works. So you basically lower your expectations a little bit. You know that the model can make mistakes and why they are making them, and how. And so when you think about tokens, you get some intuition about what you can do in order to avoid that, what you should do about it. But tokens are also about the speed. So depending on which model you are using, if it's reasoning one or not, how big your response is, and so on, it will have to do with the response time of the model, but it also will have to do with cost, because you pay per token. We'll talk about the cost as well, but keep that in mind for now. So let's get back to the code. So far, I was showing you the OpenAI API, and that works, right? And that's perfectly fine. But then we will do something different. We will import LangChain library, and from the LangChain library, we will import OpenAI client and bunch of extra objects. And let's say now we would like to create a kind of joke teller. So we create a system message. The meaning of system message is you have system message and human message, and the meaning of system message is your way, your as an engineer way of controlling what the chat does, what the system does. So you can provide a very specific instruction what it can do and what it cannot do. And that's your kind of first mechanism to prevent from sneaky users which try to do something harmful, something sneaky, something bad for your company. Of course, it's still related to token generation, so it will not be perfect, but it's quite powerful mechanism, and definitely you can do that. But what we do now, we just say that you are an expert in telling jokes, and then the human comes and says, okay, tell me a joke about a specific topic. The topic we define here, we pass it later on here in the invocation. So there is like templating system, but then all we do later on, we create the API, we select the model, and we do the invocation. So we pass the prompt to the API, we get the response, we print the response, but there is another way of doing exactly the same, and that's where the chain in LangChain comes from. So we have this pipe operator, and the way you read the pipe operator is what is here actually goes as a parameter here. So two ways of doing pretty much the same. You can print the response itself. You can print the content. Usually content is what you are mostly interested in. So it returns an AI message object with the content of the actual joke. Why do birds have hairy coats? Because they look silly in sweaters. Yeah. Whatever. So we did not expect the jokes to be extremely good, but we already are using LangChain, and we already are using this operator, and we will be using this operator a lot. And now the question will be, okay, and we can use a little bit more, like chain those operations a bit more, so we can pass the prompt to the API, then we can pass the result to string output parser, which is an object from LangChain, and you can handle those responses, and you can chain more and more operations. But then the question will be, okay, but is it that much different from what we've seen from the OpenAI library? So if we stop here, and if we have a look at what would have happened if we wanted to change our application to use another model from another company, from Google or from Anthropic. If we scroll a little bit up, you could see that OpenAI wanted us to basically pass model messages. The messages has a specific format, and you really need to basically pass the format in a way expected by OpenAI. But now if you are about to change to Anthropic, you would have to redo that. So figure out what format it expects as an input, how to handle output. And what we can do instead, we can just import LangChain chat Anthropic, so completely different provider, define the model we want to use, and okay, something went wrong. Okay, I don't have the token here, but anyway, you switch, it doesn't really complain about the actual input, it complains about connection to Anthropic, but you use exactly the same chat prompt you used before. You just pass the same chat prompt to Anthropic API, and you basically switch to another model. And that's especially important if you expect to experiment a lot with various models, or if you want to support multiple models for multiple customers, and so on. So to sum that up, the reasons we need framework is first of all about the abstraction and simplification. You don't really need to think about the details of each and every model. If you want to use many of them, LangChain simplifies that for you. Then LangChain has quite a big community. If you go to their GitHub, you can see like really many stars. You can see pull requests, open issues, and so on. So it's quite an active project. And last but not least, it has many tools you can use. So it has implemented all types of connectors to databases, because very often you need to pull information from a database which you provide to the model. You need to parse PDF files. You need to pull data from website and then parse that. All of that is already implemented and you can use. You don't have to reinvent the wheel. So let's think about use cases. Of course, you probably are using LLMs for daily work, ChatGPT for emails, Copilot for or Cursor for code reviews, code generation, and stuff like that. But we can think about like those low-hanging fruit use cases, which you can implement like 30 minutes after you leave this presentation in your company. So all things like sentiment analysis or text categorization is a really low-hanging fruit these days. So what do I mean by that? If you have, let's say, if you run a company like Booking.com, and if you get comments from the people using your website, so you get comments about hotels, like whether the stay in the hotel was good or not. And let's say you have just the text. If you have just the text, of course, you can go and read that and so on. But if you want to get some numbers, then it becomes not that simple, simply because it's just a text, right? And sentiment analysis is really not something new. It's not something super fancy. It's that there used to be sentiment analysis model before LLMs. The problem was they were either not that good, or you need to tune them for your need. You need to train the models and so on. But these days, getting this extra column which says whether your comment is positive or negative, it's basically a no-brainer with LLMs, and pretty much any LLM can handle that. If you want to know more, if you want to know the category of what the comment is about, whether it's about checking or the staff or the food, you can get that as well. And all it takes is really about writing the good prompt and writing back the results. So, and the prompt actually for that use case doesn't really have to be that good. So if you write something like, "You're expert in sentiment analysis, justify if the website comment text provided is positive or negative, answer in one word, positive or negative." And let's say we have comments. Of course, these are just 3 comments in a list. Normally, you would have to write a connector to your database and so on. But then you just create API. The nano model would be probably good enough for this kind of use case, because it's super simple use case. So it's the simplest, like smallest and cheapest model from OpenAI. And then you create a prompt. You create a prompt which is a combination of system prompt. So this is a system prompt, what we are supposed to do, what the system is supposed to do. And then as a human message, we basically will be providing comments from the list we'll iterate over. So for each of the comment, we could be doing batch here, but it's kind of simplistic implementation. So for each comment, we want to run that prompt, and then we just print out the result to see what has happened. So the first comment was negative, the other 2 were positive. And once again, probably you would like to store that into database, but that's a completely different story. But the whole message here is about that this code pretty much fits into one screen. You can do that very quickly. You can do that unless if you don't have like hundreds of millions of comments, it wouldn't be that expensive, and you can get this kind of functionality almost for free. And before LLMs, it would have taken much more time. And I would like to show you one more use case we actually had, and it was about generating training data for ML. So our customer had a job classification model, and it was pretty much about understanding if 2 job descriptions are the same or not. It was kind of marketing company doing targeting people looking for a job, and it was about understanding if Java engineer, Java software engineer, Java developer are the same job, and they are pretty much the same job. Then not every recruiter knows that, but JavaScript is something different, so they should land into 2 different baskets. And the problem was that the model existed, the model was working, but the model was only prepared for German, and the customer wanted to build such a model for other languages, and they only had labels, the data they trained the model on, only in German. So what you can try is you can try LLMs to generate such a data for you. So you can use direct translation from German to other languages. And that actually didn't work that well for us. But you can also try generating synonyms of a specific job title in specific language. And that worked much better. But coming back to our kind of token generation, and that it's every now and then it goes completely wrong, we saw examples of job like carpenter, and most of the time the synonyms were working good, but every now and then you saw results like the synonym of carpenter is the knight of wood, which doesn't make any sense. So all you need to do in this kind of cases is you need to kind of run it multiple times, test, have a look at the results, and maybe join the results. So you take the most common occurrences to basically to remove the long tail, because every now and then you get completely wrong answers, and you need to be aware of that and understand the business risks and how to prevent that, whether you go through that manually or just a simple filter is good enough. So let's go back to the code, and Now, I would like to show you something about RAG, which stands for Retrieval Augmented Generation. So the whole idea is about pulling some extra data and providing it to an LLM. And here we have a very old model from 2021, I believe. And the problem with that very old model is when you ask it for a LangChain, it will not know what it is. And actually, the problem, which is general to language models, is that it won't just admit that it doesn't know. It just generates tokens, right? So it will come up with an answer which makes no sense. It just see, okay, lang, so it's about language, and chain, so it's about blockchain. So it says it's a blockchain-based platform that aims to revolutionize the language learning industry. And it's like very convincing if you don't know what that is, but if you know that LangChain is a Python framework, then you see it doesn't make any sense. But if you think about reasons why it happened, is basically LangChain was not trained. Sorry, the GPT 3.5 turbo model, the old model, was created a long time ago. Probably it was not trained on any data about LangChain. So it comes up with responses. But what you could do in that situation, let's say you want to summarize what LangChain is and you know where the documentation is. So you have this link. If you go there, it's just a simple page, simple intro page about LangChain. Nothing fancy, probably like if you print that out like 2 or 3 pages. And you explicitly say that you want to get, oh, speaking of tools, a tool from LangChain, which is for loading URLs. You load that URL, you parse it pretty much, and you get this variable, which is called introduction, and it's basically a string with all the description from the page. And if you use that introduction variable and create a prompt like, help me understand what LangChain is based on the content of the file with its introduction. And we basically pass the introduction as a helper to the model. Even the old model could do quite well with reading that and basically summarizing it for you. Like LangChain is a framework designed for developing applications that utilize large language models, and so on. So the whole idea here is that if you build an application which is supposed to know a bit more than the language model knows so far, if you build an application which, let's say, relies on what's in your database, or if you want the model to know about the recent events, you need to find a way of providing that information to the model. Here we just knew exactly what we need. We provided it to the model, and it's all about retrieval. So that's the R in the RAG, Retrieval Augmented Generation. And let me show you one more thing very quickly, which are vector embeddings, and I will get back to the slides. I'll explain what they are for and why they at least were so popular, but why they're also not perfect. So what we do here, we have some strings. Those are simple words, but it could be much longer text. And we use 2 libraries, one open source library and one API from OpenAI. And we use them to basically transform those words into set of numbers, into vectors. Then there is a bunch of boilerplate code, which is for reducing the dimensions, because the vectors you are getting are hundreds or thousands of dimensions, and I want to print that. And then we are plotting it, and we represent those words somewhere into a multi-dimensional space. But why am I showing you that? Let me get back to the slides and let me show you. Let's imagine that you would like to build a travel assistant able to answer customer requests, customer who is looking for a booking, let's say. So when the customer says, I need an apartment with elevator in London, you have to have a way to provide the model with information about what's available. So what apartments you have available for a specific date, what is the price, the customer can ask about the price range and so on. And the model has no chance of knowing that, so you need to provide it to the model. So in the same way, we did that with the LangChain documentation. We provided the model with LangChain documentation. In the same way, we can provide the model with records from the database. We can provide it with results of specific API calls, and so on. And then the question will be, but where the vectors are, why did I show you the vectors? So one of the quite popular approach is that if you have text, if you have documents like PDF documents, if you have all kind of wiki pages, if you have even text description in a database of like descriptions of the apartments, all the text you can, each individual text you can transform into a vector. And the promise from the vector embeddings would be that a specific text will be transformed into a set of numbers. And if two texts are similar in meaning, then the two vectors will also be close to each other. So the vectors represent how close to each other specific texts are. And there are a few more promises from the vector embeddings. And I'm kind of emphasizing the word promise, because then we will challenge that promise. So when you have word king and queen and men and women, you should be able to do math on top of the vectors produced for those words. So king and queen is pretty much the same job description. So you should be able to do the math and understand that, okay, the only difference is gender. So queen equals king minus man plus woman. And then if you represent various words on in the space, you hope that colors will be somewhere close to each other because they have the same meaning. Then king and queen will be in somewhere else, but also close to each other. And then car would be somewhere else. But that so far is so simple and so naive. Like how do we use that? The assumption here is that if you have a question about if you have a request about apartment with elevator in London, then that question should be closer to the actual description of the apartment with elevator in London, and not that close to an apartment which doesn't mention elevator. So on one hand, it's super bold assumption that it will just work out of the box. But on the other hand, I wanted to emphasize that there are cases when it's actually quite smart system. So let's say you are asking about apartment with elevator in London, but the description of the apartment says about lift. So this is what vector embeddings are quite good at. They understand that that elevator and lift are the same words, and in that sense, vector embeddings are better than just a keyword search. But later on, we will see how exactly it works in practice. I can tell you that it's not that simple so far. And coming back to this request, if you have this, I need an apartment with elevator in London, what you can do is you can get all the descriptions you have, you can transform them into vector embeddings, store them, and provide a mechanism for doing a lookup based on the questions the customer asks, and assume the best matches according to the vector embedding are the best matches ever, and use them into providing requests to your customers. The reality is this is just one of the tools you can use. I will be talking a little bit more about other techniques and other tools you could be using. So in reality, you have really many candidate documents. If you store all of them into vector embeddings, you might realize that that all of them are so similar that it's impossible to decide based on the difference from the vector similarity score which to select. And very likely you realize that it will not be enough. Very likely you will realize that you need to think about data quality and adding the metadata to the just raw description, and that you need to add specialized tools for specific types of records or specific type of metadata. So based on metadata, you realize that specific description could be handled in a different way. And you can use LangGraph, which is part of the LangChain project, in order to do a little bit more fancy orchestration of smaller, dedicated, and well-crafted tools. But overall, it's a tool which is good to be aware of. And probably if you are into the subject, you could see quite a hype about that. The hype is a little bit down now because it's definitely not a silver bullet. And let's keep that in mind. I'll get back to that in details a little bit later on. But what I wanted to mention before we get back to the code is if you have a query like that, usually the communication with the customer is not just a single query. That would be a very naive assumption. Usually the communication goes, oh, I need an apartment with elevator in London. And then when customer cannot find what he wants, then he says, oh, whatever, skip the elevator, but I need washing machine. So now you have like two sentences, two statements. You have the word elevator twice, but the word elevator doesn't really matter, because what matters is I wanted elevator, I don't want elevator anymore, so we don't care about that, but it should be in London and it should have washing machine. So you could as well condense that question into I need an apartment with washing machine in London. So it will be a lot, when you build a real application, it will be a lot about finding a way of handling the history. So first of all, to have the history of the conversation, what happened in the conversation, what happened in the customer context, because sometimes you don't really talk about single conversation. Sometimes you need to really pull out information of what happened in the past from some CRM system or something like that, and provide the information to the LLM in the most condensed way possible. But let's have a look at how we can handle history and condense questions in the code. So, okay, once again, we are using this old model because we've been providing the LLM with info about LangChain, the introduction file. And we have this prompt about help me understanding what specific tool is, this time Langsmith, based on the description from the website. But then we define another prompt, which is asking a follow-up question. How does it work? The problem with that is that this prompt has nothing to do with this prompt. Those are completely standalone. So when you define a chain based on the first prompt, and then another chain based on the other prompt, and then when you do the invocation for one and the other, you print the results, you see that the first response is basically correct, is what you wanted, that Langsmith is a tool within the LangChain framework that allows user blah, 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 blah. It basically uses the information from the description we provided, but then oh, I'm really surprised. Then we ask, how does it work? And what does it say? I'm curious. It works through combination of hardware and software processes. The hardware processes involve data being input through devices. It just comes up a question, answer to random, how does it work question, but let me run it again and see if it will come up with the same or not, because it didn't make sense in context of the specific process can vary depend on what you are referring to. So I'll provide a general overview of how things typically work and so on. If I run it again, I guess it will be, eventually it will be smarter. Oh, this time it says it's not clear what specific technology or process you are referring to. So basically it doesn't know what I'm asking about, and we need to provide some way of knowing what has happened in the past in the conversation, on what context we are asking the question in. So what we could do, we could use a few tools from LangChain, very simplistic ones. So we have conversation memory buffer, we define the memory, and we define a conversation chain where we pass the memory object. And when I ask what is 2 + 2, it actually rewrites what I ask into a hard-coded prompt the tool has. The following is a friendly conversation between human and AI, and so on. It does provide extra instruction, but what's important is it also keeps the conversation within the prompt. The current conversation so far is that, what is 2 + 2? It's my first question, right? And now it expects the answer from AI, and the response, the actual response, is 2 + 2 = 4, and some extra boilerplate text. But then when you ask what was the result, I forgot, it is actually able to pull the same prompt, but also pull the history. So what is 2 + 2? 2 + 2 = 4. So that's the conversation so far. And now it's time for AI to answer. And the response is the result of 2 + 2 is 4. So I don't explicitly ask about 2 + 2, but it remembers based on the history. So this is one option. This is one option of keeping the history, but that option is not perfect because it, first of all, keeps all the conversations. So you can imagine that the conversation will be growing really fast. And if it's growing, then that means you pay more for the tokens. It's more likely that the LLM will get lost. And overall, it doesn't really take into account anything about schema. It's just it basically takes human AI. So it might get lost within the text as well. So it's usually better to keep the context using some specific schema, so to keep control of the type of what's meaning of what and so on. But then what we can do, we can try to first of all do the trick I was showing you on the slide with the washing machine question, so condensing the question. So we're creating another prompt, which is given the following conversation, the follow-up question, rephrase the follow-up question to be standalone. So in other words, what we want to achieve is that if you have a conversation which goes like that, how do I implement RAG in LangChain? And then the answer is, in LangChain, you can use predefined class. And then you ask a question, how does it work? It should be rewritten to something like, how does the conversation retrieval chain class work? So you want to rephrase the question into be a completely standalone question without any history, let's say. So you provide a prompt like that, you provide the input, and you expect the standalone question to be produced. And we still are dealing with the history, so we know the the context, and then based on what it should be created. So if we kind of simulate the conversation so far, in the memory object, we are saving the question and the answer so far. Then when you ask, how does it work? And you run it on top of the condensed question chain, you get a question, how does it work, to be rewritten into how does conversational retrieval chain work in LangChain for implementing retrieval augmented generation. And this is just one simple technique. In most cases, you really want to understand what's important in your business. What are you optimizing for? How does your conversation go? Is it about keeping the information from the conversation, or maybe providing some context from an external database? So what I'm showing you are just basic techniques to start with, and they are kind of good enough for demo. But most of the time, you probably will spend weeks of understanding what's important for you, how to keep the history. But here you have an example of kind of handling your own history. So what we have here, we have a few functions: get, question, and history. So what we are starting with is just an input string, which is your question. And then what we're returning is a map. And it's a map because LangChain, this pipe operator, expects that the call before is returning just a single object. So when you pass the output from here to here, it should be a single object. So we are wrapping that into a map. So we wrap a question into a map, and the other key in our map, in our dictionary, is history. And we start with fresh history, but later on, we make another call, which is get answer and pass question through. So what we do within that function is we are actually doing another LLM call, which is basically calling our prompt, passing it to the model. So that is the answer we get from the model. And then we really need to do something with the answer. So we need to pass the answer further, pass the question further. So in the function update history called here, in the function update history and return answer, we can get, once again, the input dict defined here. We can save the context, and we are saving that the question was this, and the answer received actually here was this. And this way, we basically pass through the messages between the calls. So it very much depends on what exactly you want to build, but this is kind of the simplistic way of building that. Then you can see it's just a Python code, so you can come up with pretty much whatever you want. And in some cases, keeping the entire history is fine. In some cases, you want to condense the history because you don't want to pay so much, or maybe you want to make sure that it's extremely precise about very specific information. So most of the conversation does not really matter, but you really are into a specific information. So you want to keep that specific information somewhere on the side and make sure it doesn't get lost. But it's very much up to you. And now I'll hand over the screen to Bartek. I'll send you guys another notebook, and he will show you a few more advanced techniques, as a food for thought of what you can use it later on if you want to build something a bit more advanced.
And Marcin, you need to stop sharing, so I can start. Okay, can you see my screen?
I can see that, yes.
So basically what we'll be showing now is function calling and tool use. And this is a method to get a structured output from the model, because the model can generate text, and the idea is simple. Let's ask it to generate a specific format such that we can easily parse it in our system. And the most common format is just a JSON. We can then load it into Python classes or any other objects, and we can automate a lot of things using the LLM, because when it generates just pure text, it's not manageable to automatically use it later in your system. And this notebooks shows the approaches to getting structure output from the model. And there are 3 ways to do it. The first one is called JSON mode, and it's actually, I think, being slightly depreciated. It's still used in 4.0 family of models, but later models use either structure output or function calling. And what's the difference between those 2 approaches? Structure output is, according to OpenAI documentation, should be used when you want the model to generate the output, and this is the end of your interaction with the model. So basically you want it, for example, to generate a graph, and once it does this, there are no further turns. And function calling should be used where you want the model to call different functions in order to get the informations or the data it needs to solve a given task. And it's probably the most popular one because it's used in agentic frameworks where the agents interact with your environment, and they use function calling in order to get this information in a structured format. So what I want you to understand from this slide is that there are 2 approaches. They are very well described in the documentation. And if you decide to use one in LangChain, it's very simple because you just specify one argument when defining the model. And in this notebook, we present how to set it up in Python and how easy it is with LangChain to work with LLMs and with structure output. So the first cells, here we use Pydantic library to define classes. And what Pydantic does under the hood, it provides you with serialization functions. And LangChain under the hood uses this function to send the schema of your classes to, for example, OpenAI API, and it uses it later to parse the response from the model. So for example, you want the model to generate a joke. So you define a class which has 2 members set up in a punchline. You define their types, you define the descriptions, and one thing to note is that if you define it like this in Pydantic, then this description is also being sent to the model. And it's very useful for more complex schema, because sometimes just from the name of the member, it might be hard for the model to guess it right. So it's useful to add some descriptions, and this description is also being sent to the model. And here we use this function with structure output. And what this function does, it binds this joke class to the model, and under the hood, LangChain will send the schema to the API, and it will generate the output in a specified format. One more thing we are showing here, it's a tool called Langsmith, which Marcin tried to introduce using chat. And chat doesn't know a lot about Langsmith because it's very new. It's even it was created later than LangChain, but it was created by the same people, and it tightly integrates with LangChain. And basically, this is a tool for monitoring and observability. And what it does under the hood, it traces all of your calls to the LLM. So what we do here is we make a call with the structure output to generate a joke. And under the hood, Langsmith captures everything what happens there. And I ran this notebook yesterday in order to go through it faster today. So I will show the traces from Langsmith from yesterday. And if we go there, what you can see is a dashboard that for a specified project tells you all of the relevant information you want to have. So for example, you see the total number of tokens, their cost. So when I ran this notebook yesterday, it cost 5 cents. You get the important details about the latency. So is your program actually running fast? What's the mean response time and so on? And per each interaction with the LLM, you have the trace logged here. And this trace corresponds to our example with joke. So the high level tells us what was the input and what was the output. And then we can check each element of the chain. And this is very useful because, for example, the call to the model might went fine, and you get some string output, and the error happens during parsing. And then in this view, you can easily diagnose which step of your chain breaks, what are the inputs, what are the outputs. We can see that the model has one tool, joke, and the output is actually in JSON. What happens next is we have this pydantic tool parser, which is basically a wrapper around some pydantic functions that will take this JSON and will instantiate the joke class. And here the output will be the object. And Langsmith is very useful because you don't need to do anything in order to make it work. The only necessary step is actually to provide the key and to set the tracing flag to true, and it will capture all of the informations you want to capture in a LLM project. Okay, so let's go further. Here we will also try to introduce or maybe show some information about LangChain in on a knowledge graph. And in order to do so, we can, for example, load LangChain documentation. We can use also a class from LangChain, which loads the given website in a markdown folder, in a markdown file, or in a text file. And then we can define our knowledge graph schema. So basically we have nodes, we have edges, and knowledge graph, it's a list of nodes and edges. We instantiate a model. The first one we will use for O. We bind it to the knowledge graph using this with structure output function, and we call it with a prompt, help me understand what LangChain is, as a detailed knowledge graph based on the content of markdown file with its instructions. And here we pass the instructions. And using GraphVis library to then visualize this graph, what we get is this image. Let me check if I can make it bigger. But I think it's visible. So what the model does, it tries to break down what's in LangChain introduction page into predefined structure, which is our knowledge graph. And it's very nice because it works out of the box. You can basically, instead of using just chat with text output, you can define some more advanced schema and make the model generate it. And of course, there are some limits. For example, if you ask it for 10,000 nodes in this knowledge graph because you want to really understand every concept, it will probably not generate that many. Yeah, but then we can compare the output to more recent model. In this case, it's 5 nano, and it is a reasoning model. You can also choose the effort for reasoning. Basically, higher effort will take longer, cost more, but the promise is that the output will be of higher quality. And even the nano model with reasoning effort low gives, I would say, a more verbose diagram, and just, I think, much more advanced than the one from 4.0 model. And here we also ask it about some random stuff. For example, explain me the full process of manufacturing plastic bottle with all of its dependencies. So you get the idea. You can have the model generate the output in any schema you want. You just need to define it upfront. And in most applications, you just need to think about how to display it. But it is also quite easy to achieve these days because you can use tool such as Lovable or V0 to generate your frontend. And under the hood, if you have the schema defined, you can generate or populate the elements in your UI using this kind of approach, and it works fine out of the box. What you need to pay attention to is that if you pass too complex schemas, so for example, you have a enum that has like 10,000 fields, then I think the API will not even allow you to do it. But in practice, if there are a lot of fields, you need to use a bigger, more expensive model because smaller models will not get it right. Okay, and once we have the structure output introduced, we can smoothly go to agents. So what is an agent? Agent is an LLM that has access to tools, and a tool is, for example, Python function that the model can generate JSON with inputs to this function. And the model, once it generates the input to the function, we as a users, we invoke this function and provide it with the result of this function. And in that way, the model can interact with the environment and with the surrounding world in order to make some tasks. So for example, it can have a function to modify a file in your code base. It can have a function to interact with your GitHub repo. And in that way, you can build a coding agent that will modify the files and push the changes to the repository. So what we need to define an agent, of course, we need an LLM, we need those tools, functions, and we need what's called usually executor. In agent, it's called in LangChain, it's called agent executor. And this is basically a wrapper class that each time a tool call is made by the LLM, it will parse it, it will try to execute the function, and it will send the result back to the model. And there are a lot of predefined functions in LangChain we can use. For example, there is a Wikipedia API, and there is a Python interpreter tool. So when you use Python interpreter tool, it's also important to make sure that it runs in a safe environment. So for example, you don't want to just run in terminal the code that is generated by the LLM because it can go crazy. And in practice, in production, you will probably run it in some Docker environment. But there is also this tool from LangChain you can use to experiment with Notebook, and it will run it. It will do some sanity checks and run it also safely, not in your terminal. So then you define the list of tools. And under the hood, what LangChain also does, it creates some descriptions and some parameters, some descriptions of the parameters. So what's the input, what this function does. And similarly to our joke example, this schema is presented to the model. And what's the prompt for agent? The simplest one corresponds of just the information, what are the tools? And there is this part with agent scratchpad. So basically, we need a place different than the place where the message from the user will land. This scratchpad will be used to populate it with responses from the tool. So we can in a moment see this in LangSwift. Maybe it will be clearer why we need this scratchpad. And here we instantiate the agent in LangChain. And we can call it with the task search Wikipedia for statistics regarding extraction of energy sources. Yeah, and use Python to plot the statistics you find. Basically, what it does, it invokes this tool with some search goals. It gets the output, and then it uses Python interpreter tool to generate the code. And unfortunately, in this notebook, it's not displayed properly, but we can go to Langsmith and we can go to the agent executor trace, and we can see what is happening here. So at the beginning, it calls this Wikipedia tool, and under the hood, the agent executor takes this output back. It runs the Wikipedia tool, and it sends back the output to the model. And the model can decide whether after one tool call, it wants to continue running and call other tools, or once it generates a just text message, then it means that the agent is over and it wants to present the results to the human. And there are some corner cases because, for example, what if you want the model to, as a final output, also use some predefined schema? And nice part about LangChain is that it handles it for you. So you can basically define the tools for your agent, but you can also define what's the output schema. And the framework knows like which message should be treated as a tool, be invoked and sent back to the model, and which message will be your final schema you want to get. Okay, and last part in this notebook, we show how far you can go with just predefined blocks. For example, you can use predefined classes in LangChain in order to connect to your database, and you can present the tools which are used to interact with this database to your agent, and then it can basically act as a data analysis on top of your database. And the code here does exactly this. So we create a SQLite database. There are some utility functions used also to define this. And it's about trips, about flights, and about customers and their bookings. And once we have this defined, there is predefined class in LangChain that is a SQL agent, and we can ask it what are some top 3 recommendations for a sunny trip with cheap hotel departing from Bazel. And what this agent does under the hood, it uses the functions to check what are the tables in your database, what are the tables descriptions, and you don't need to manually write all of this. The model is smart enough to know that at the beginning it should check what's the schema in your database and how to interact with it. Then in practice, what's useful to do is that if you have a very big database, you should wrap some common functions or common ways of interacting with your database in a function. So in that way, you, for example, don't risk the LLM will generate a invalid SQL. Rather, you ask it to combine the interactions with your database from some predefined functions you have prepared for it, because you know that the usual access pattern looks like this. And we can also have a look at this in LangSmith. And this one is about top 3 recommendations. And also, if you have a look at the cost, one thing about LangSmith which is still not implemented is caching. And basically, when the agent runs, each time it sends the same history to the model. And in practice, what those costs are not that high, because most of the LLM providers, they support caching out of the box. And it means that each time the same history is sent to your LLM, it will be read from the cache and it will be cheaper. And this is one thing to remember when you use LangSmith with agents, that it usually shows much higher cost than the actual, due to the fact that it doesn't count those caching tokens. Okay, and this is the end of the structure output part. And if you have some questions to it, I will be happy to answer them now. Or if you, Marcin, want to continue, we can make it also at the end.
Yeah, I guess maybe you're right that it was quite overwhelming. I have quite a lengthy summary, but we have 15 minutes only, so maybe while Bartek is still presenting this notebook, maybe you guys have a question now. I count to 3 and I take over the screen. 1, 2, 3. Okay. So I share the screen. Could you please stop sharing?
Yeah.
Thank you. Okay, so I share again. I hope you can see my screen now, my slides.
I can see.
Okay, perfect. Yeah, so coming back to all that discussion about this example of travel agent. If you look at the website of a vacation rental company, it's basically description of, this is a description of cottage in Cornwall. It's somewhat cheap, it's somewhat small. And then another description is from an apartment in London, a bit bigger, much more expensive. But for vector embeddings, these two descriptions look exactly alike. And I know you cannot read what's in the middle, but that's exactly why I put that, because that's exactly what engineer is struggling with. You have many descriptions, all of them, they like business-wise, if you go into the business details and what customers are looking for, they look very different, but from generic vector embeddings model, they look very much alike, and you have to find a way of distinguishing between them and distinguishing what's relevant for a customer's query. So overall, the general conclusion is that magic does not exist. There is no such thing as silver bullet like vector embeddings or any other tool. Very often, you really need to find the tool for you. So problems with delivering context to LLMs is about the context length. If you provide too much, it might be that it won't just fit the context windows because they are limited. But even if it fits the context window, the LLM might have problem with extracting what's important. And that's your job to find a way to provide them the best and the best chunks of information. So the better the information, the better context you provide, the better results will be. So if you have, let's say, if you deal with really big PDF documents, you might think about splitting those documents. And then if you split the documents, yeah, it's a simple description, right? You have big documents, split that into chunk, but it would be like saying that splitting documents is like drawing two circles and then completing the owl, right? It's not that simple. So usually you need to think about context of what you are, of your chunk, and the context in case of PDF document would be, let's say the chapter, the context, and page the chunk is coming from. Because if you don't understand that, the chunk might be completely useful. And there are other techniques like using LLMs, which we have described on our blog. You can basically search for what self-query is. And when you deal with PDFs, as I mentioned, you always get into those tricky formats. So what happens if a PDF has a table? What happens if it has a diagram? What happens if it has pictures? So it's also about assessing what kind of challenges you will have, how much time it will take, and if it makes sense from the business point of view to investing into that specific use case, or maybe you need to search for a little bit easier, a little bit kind of the one which is providing the return on investment faster. And you can always, if when I mentioned that the vector embeddings are not really the silver bullet, you can always try hybrid search. If you have backend database, Postgres, Elasticsearch, all kind of APIs. If you have them already, you can try using the data out of there, but it's still about exactly the same challenge, how to spot the piece of information which is the most relevant. Very often you need to pull more information than you need and then have a tool which is basically specialized in selecting the best ones based on your specific place in your application, where you are, what question you are answering, and which documents are the most relevant. Very often you might want to try all types of pre-processing using LLMs. So you add metadata to your database, so the lookup is easier. So then you can use either your databases or specialized agents to basically select what's the most important. So it's always more than just splitting documents or selecting records, transferring them into vectors, and then selecting the closest vector. That definitely won't happen. It's good for demos, but if you really want an application, a bit more complex application, you definitely need to think about metadata you have. You really need to think about where and when to apply some special rules and what really matters for your customers, where you need to put a bit more effort and experiment, and where it's basically good enough. You very likely would have dedicated agents for smaller pieces of work, so agents which are good at specific piece of work. But at the same time, it's, again, not that simple, because you can have many dedicated agents. And then the question will be, how do you orchestrate them? How do you make sure that the right agent is being called? And how do you make sure that the agent is getting the right context? And context will be the information you pull from your database, but also context will be why the agent was called, what has happened before within the application, and so on. So it's all really about very, very careful engineering of that. And then, of course, at some point, you will have to answer the question about hallucination and what do you do about them. And it very much depends on which use case you are implementing. In some cases, you have human in the loop, and it's perfectly fine if every now and then the model makes a mistake, so human reruns that, verifies that, and it's not a big harm that there is a hallucination. In some cases, you really need to work much harder or even not use LLMs because the consequence of the hallucination is too large. But if you are at the situation that you have the model, you have the system using LLMs, and you would like to limit the hallucination, so you can afford some of them, you have a ways of recovering from them, but you would like to limit them, there are a bunch of tools as well. So for instance, there is this tool called Nemo Guardrails, and they implement all types of verifications and kind of LLM as a judge and things like that. So for instance, let me just quickly scroll through that because we don't have that much time. So for instance, if you ask a question, how many goals has been scored in Polish Ekstraklasa in season 2018-2019? This is a question which, well, it's not a very popular league. It's a football league in Poland. Like, who watches that? Who writes about that? And it's quite a hard question in general, because you would need to sum up the goals for each team and so on. So without lookup in the internet, it's a hard question to be answered for an LLM. They are not trained on that data, and you get 3 completely different responses. And what the tool does, it asks that question, but it asks that question 3 times, and then it does this prompt in the background. You are given a task to identify if the hypothesis is agreement with the context below, where the context is one of the answer or 2 of the answers, and the hypothesis is the 3rd answer. And then the bot responds that it's not in agreement, and it's flagged as hallucination. I just wanted to also emphasize this colon. This colon is a hint to an LLM to basically go right away to the response, yes or no, without this boilerplate text like, yes, I can answer the question, the answer is no. That wouldn't be very useful here. But overall, this tool is a nice inspiration to have a look of what can be done with LLMs. It doesn't necessarily mean that I recommend you use that, but I recommend getting familiar with that so you can see various techniques they apply. But when you do these types of verifications, you really need to think about the consequence of them. What will be, for instance, the cost of false positive? How expensive would it be? Because you need to make some extra LLMs calls. So that's one cost, but the other costs would be about your system will be basically slower. And all of that, you really need to think when you decide to build an application, when you make the decision, when you build it. So overall, we are kind of back to square one, in a sense that a lot is about context, a lot about is about data quality, delivering the right data to the LLM. A lot is really about careful engineering. Because if your assumption is that this approach will work, that the approach that shut up and take my money, I'll buy some tool which will magically solve my problems, that probably will not happen, partially because most of the businesses are more complex than that, partially because the tools are quite new. So, and they are changing quite a lot. The models themselves, they are changing as well. So this is something you really need to pay attention to. You really need to pay attention to tests. You test the retrieval, but which is deterministic, which is great. So how you pull the data, but also you need to test all the actions based on LLMs wherever you can. And I say wherever you can because I understand it's very tricky. It's not deterministic, but still testing helps, partially because it helps you with the further development, but also partially because the model themselves changes in the background. And every now and then you see some change in the behavior of the model without any notification. So that's also something to be careful about. And if you run the system, you really need to collect the data about user behaviors, about the responses, all these kind of tools for observability like Langsmith. It also helps you understanding what is happening if the users are using your system in the way you expected them to do. Keep in mind privacy, that when you get the data from the database and process that in the application, that data is being sent to the provider. In some cases, it's not really acceptable. In those cases, you might need to think about an on-prem LLMs, and that means you really need to think about the cost, because you will be using on-prem LLM, which is open source, and it seems to be cheaper option, but then you really need to think about the infrastructure. You need to buy the infrastructure, you need to maintain that. And likely if you use especially smaller model and some model which is behind the state of the art, likely it will take much more time to optimize that. So it might happen not to be that much cheaper. The other risk with open source model is that they are not really open source, they are open weight. So you don't know how they were trained, what data they were trained on, and you really need to basically accept that. Then when it gets to cost, it seems to be simple when you are using API like OpenAI or Google. You basically calculate the input tokens, output tokens, but then the tokenizer differ between the models, so it's not the exact calculation. You have reasoning models where you have tokens in between, which you don't really explicitly control. So you don't necessarily pay only for the output, but also for what happened in between the reasoning. When you deal with the open source model, the calculation is much, much harder, because you have to take into account the hardware cost, which you pay upfront before you even know if the project is doable or not sometimes. And you don't have a static cost per request. So if you have not that many requests, the single request will be very, very expensive. There will always be risk. It's a risk of wrong answers. And in some systems, it's like rocket launching, it's much trickier. In some systems, it's not that critical, but you need to understand how critical it is in your business. You need to calculate the cost and know about all the hidden costs on the way. You need to think about things like license of a specific model and how exactly you will be using that data, and whether you will be able to use that data later on to maybe train your own model and stuff like that. But overall, you really want to experiment. You really will be needed to experiment, but make sure you don't get stuck on the experiment. Make sure that you think about the business goal first, because experimenting is nice, but you really need to be pragmatic and make sure that the project you are building makes sense in your business. Thank you very much. I would really, really appreciate if you scan the code and provide us with feedback, but I'm ready to answer your questions if you have any. I keep the code on the screen.
Okay, so now we're gonna leave a few minutes for questions. So if you have questions, type in the chat.
Oh, typing in the chat, or okay, we cannot talk, right?
Yeah, no typing in the chat.
Thank you, Darko. It's super nice. I'll get back to the presentation. So if you didn't scan the code, I would really, really appreciate that. But Bartek, please observe the chat. If there are questions, I'll also jump back.
Let's say 3 more minutes for the questions.
Okay, the last chance to scan the survey form, and I will again say I really appreciate if you guys fill that in. And I'll also show my LinkedIn and like newsletter sign up form if you guys would like to hear from us every now and then.
We have a question. Can you see it?
Okay, let me see. Mm-hmm. Okay, so that's a very good question. The question about security. So it very much depends on the client. I've seen customers who are in exactly the same, both are in EU, they are in the same business, and one of them say, yeah, we have a contract with OpenAI or with other in that case. And we have SLAs, and they promise not to that the data is safe and it won't be used for training and stuff. The other company is like, oh no, wait, we have to have our own infrastructure, like hybrid infrastructure, and LLM is the part on-prem, and we are helping them building their own. So it very much depends on regulations, but also the trust of a specific company and the legal team and the security team. But you always have the option of going with your own infrastructure. The only caveat with going with your own infrastructure is it's quite a big investment up front. So if you're a large company which understands that there is no other way but investing into LLMs because everybody will be doing that, then that's fine. If you are a startup or a smaller company, I would really suggest to verify your idea before you do that, and it's much cheaper with basically APIs, simply because, as Bartek was showing, we for running what we've been running, we paid like $0.something. So building that, it's simple and it becomes and cheap, and it becomes costly when you have the scale. Oh, are there any on-prem options you know of? So NVIDIA has quite a heavy tool called Nemo, and they support all the life cycle, but it very much depends on what life cycle you are thinking about, whether you are thinking about training your own LLMs or at least fine-tuning them at some point, or you're just thinking about serving it on 1 or 2 machines. If you want to serve it on 1 or 2 machines, it's better to basically deal with Kubernetes and building a bit of simple custom API and basically starting working, and then seeing what exactly are your needs in the future, instead of kind of betting on very big machinery, let's say. Bartek, do you want to comment on that as well?
No, I think this is the main option.
Okay, since we kind of broke the schedule already, you have contacts from Marcin and Bartek on their presentations, so you can ask them after the tutorials. So thank you, Marcin and Bartek, for an amazing tutorial.